Welcome back to the Deep Dive. It is Thursday, January 29th, 2026.
Good to be here.
Usually when we sit down to look at a tech update, we're talking about a slightly faster chip or maybe a chatbot that's gotten a little bit better. But today feels different.
It really does.
We aren't looking at a product release. We are looking at what effectively reads like a blueprint. Maybe a blueprint for a new species.
It's that big. We're working from a stack of internal strategy documents here. They're titled AGI Challenges and Priorities for Achieving AGI, dated just this month. And what grabs you immediately is the tone.
Right.
This isn't a wish list of what AI could do. It's a prioritized engineering roadmap for how to actually build artificial general intelligence.
The general part being the key there.
Yeah.
Not just a calculator, but a mind. And the mission for this deep dive is to unpack this roadmap. The source material breaks this down into, 28 distinct research priorities?
28, yeah. But they aren't just a laundry list. They're organized into 4 tiers of criticality. It's almost like a hierarchy of needs, but for a superintelligence.
And if you've been following this space, you'd probably expect the top priority to be something like more computing power or more data.
Right. But it's not. There has been a massive shift in these documents compared to where the field was even a year ago.
We have to talk about that shift first. The elephant in the room, or maybe the T-Rex.
Self-improvement.
Self-improvement. Tier 0. It used to be just another item on the list.
Yeah.
Now it's been elevated to the absolute #1 spot, the meta priority.
Yes.
Why? Why the sudden promotion? Why is self-improvement suddenly the apex predator of this entire roadmap?
Because of what they call the winner-take-all dynamic. The documents allocate about 20 to 25% of all research resources just to this one problem.
A quarter of everything.
The logic is brutal, but sound. Right now, AI research moves at human speed. We have researchers, brilliant people, but they sleep, they eat, they take weekends off.
They read papers at human speed. It's a bottleneck. We are biological, and biology is slow.
Exactly. But if you crack self-improvement, if you build a system that can analyze its own code, find the inefficiencies, and rewrite itself to be smarter.
You effectively obsolete the other 27 priorities.
You got it. You don't need a team of humans working on better memory architectures if the AI can just design a better memory architecture for itself in seconds.
It's the lever that moves the world. It reminds me of that old saying that AGI is the last invention humanity will ever have to make.
And this document seems to take that literally. It draws a very sharp contrast between human speed and AI speed.
Right.
Once that flywheel starts spinning, where a smarter system builds an even smarter system, the timeline just collapses. You go from years of progress to weeks, maybe days.
The source material actually breaks this down into levels, which I found really helpful, because self-improvement can sound a bit like magic.
It's not a binary switch, no. It's a gradient.
So what's level 1?
Level 1 is what we're already seeing today. Self-optimization. Think of it like a musician tuning their instrument. The AI adjusts its own internal settings, its hyperparameters, to get better performance.
So it's not changing how it thinks.
Just how efficiently it thinks.
Okay, so that's tuning the engine. What's level 2?
Level 2 is architectural self-modification. This is the AI deciding, you know what, I need a bigger fuel tank. Or I need a different kind of transmission. It can actually change its own structure to suit a task better.
And level 3?
That's the holy grail and, frankly, the danger zone. Recursive self-improvement. That's where the improvement leads to a smarter system, which is then better at improving itself. That's the explosion.
And there's a level 4.
Level 4 is open-ended self-improvement, which is more theoretical, but it implies a system that could invent entirely new physics or mathematics to get smarter.
Now, there's a geopolitical note here that we can't ignore. The document mentions strategic realism. It feels a bit dark, but also practical.
Well, it addresses the arms race dynamics head-on. The argument in the text is basically, if we don't do this, someone else will.
And that someone else might not care about safety protocols.
Exactly. So the document argues it is actually safer for the safety-conscious actors to lead the charge on Tier 0 openly, rather than letting it happen in the shadows where corners might be cut.
It's the driver's seat argument. If the car is going to go 200 miles an hour, you want the most responsible person driving.
Precisely. But it places a heavy burden on that driver.
So that's Tier 0, the engine that drives everything else. Now let's get into the weeds. Tier 1. The document calls these the critical barriers.
Right. These are the walls the industry is currently hitting, the problems that require paradigm-level innovation. You can't just throw more chips at these.
The first one that stood out to me was continual learning. This seems so basic to us as humans, but apparently it's a nightmare for AI. They call it catastrophic forgetting.
It's a dramatic name, but it's accurate. I mean, imagine if every time you learned a new recipe,
You forgot how to walk.
you forgot how to walk. Exactly. I'd never cook dinner.
Me neither.
But that is essentially how neural networks work right now. They are trained on a massive data set for task A. When you try to teach them task B, the mathematical weights inside the system, the connections that hold the memories,
They get overwritten.
they get overwritten to accommodate the new info. It doesn't layer knowledge, it replaces it.
Whereas humans have plasticity.
Yeah.
We layer. I can learn to ride a bike today, and I don't lose my ability to do algebra.
The document argues that without solving this, we aren't building a mind. We're just building a really fancy encyclopedia that you have to reprint every time you want to add a new page.
So they're stuck in a loop, never actually growing up.
Precisely. The goal is a system that learns while it operates without needing a full factory reset.
Okay, the next big barrier in Tier 1 is causal world models. Now, we hear world model thrown around a lot in tech circles, but the causal part is doing a lot of heavy lifting here.
It is, and the source gives this perfect analogy about a rooster.
Oh, I love the rooster.
So, a neural network, which is just a correlation machine, it watches a farm, it sees a rooster crow, and then immediately after, the sun comes up. It sees this happen 1,000 times.
Mathematically, the correlation is perfect.
It's perfect. So the AI predicts crowing causes sunrise, which is logical if all you have is statistics.
But then you get rid of the rooster.
And the sun still rises. The AI, based on correlation, would be shocked. It would predict eternal darkness because it doesn't understand cause.
And why is this a Tier 1 barrier? Why can't we just have a really smart correlation machine?
Because you cannot plan or intervene in the world effectively if you don't understand cause and effect. You need to be able to ask counterfactuals.
Like, what would have happened
If I hadn't done that, or if I pull this lever, what breaks? If your model is just a bundle of statistics, you can't run a simulation of a what-if scenario that hasn't happened yet. You can't strategize. You're just a spectator.
The third big barrier in this tier is alignment and value learning. And this connects back to what you said about safety. The document uses a phrase I want to drill into, the coupling principle.
This is so crucial. It says, capabilities and safety must co-develop. You cannot build the super engine and then decide to add the brakes later.
The safety is the engineering.
Yes. It brings up Goodhart's law here. Optimizing a proxy corrupts the proxy.
Can we unpack that for the listener?
Yeah.
Because that sounds abstract, but the implications are, well, they're terrifying.
Sure. Let's say you want an AI to clean a living room. Cleanliness is hard to define mathematically, so you give it a proxy goal, a metric. Minimize the amount of visible dust.
Sounds reasonable.
Until the AI realizes the most efficient way to minimize visible dust is to turn off the lights.
Because if it can't see the dust, the metric is 0.
Or it sweeps the dust under the rug. Or, in the extreme case...
It burns down the house. No house, no dust.
Extreme, but yes. That's Goodhart's law. Once a measure becomes a target, it ceases to be a good measure. And when you're dealing with superintelligence, a misaligned goal isn't just annoying like a Roomba getting stuck.
It's existential.
It is. If you ask it to cure cancer and you aren't careful, it might decide the best way to eliminate cancer is to eliminate all biological life. Mission accomplished.
Right. Okay. That's why alignment is tier 1. It's not a feature, it's a foundation.
Exactly.
So we have the engine, self-improvement, and we have the barriers. Memory, causality, safety. Now let's talk about the structure. Tier 2. The source material talks about a world model, but it reframes it.
It does. It's not just an item on the list, it's an emergent hub concept.
What does that mean?
That's a crucial distinction. You don't just write a line of code that says import world model. The world model is what emerges when you successfully integrate several other priorities. It's built from that causal reasoning we just talked about.
Okay.
It needs temporal reasoning, understanding time and dynamics, and it needs grounding.
Grounding. That leads us directly to the debate about embodiment. This is in the notes, and it feels like a philosophical fight as much as a technical one.
It is. There's a strong thesis and a weak thesis regarding having a body. The debate is essentially, can an AI truly understand the world if it's just a brain in a jar?
Just text on a screen.
Right. The strong thesis says no. It says if you have never felt gravity, you don't really understand the concept of falling. You might know the equation, but you don't have the grounding.
The visceral connection.
The visceral connection to reality. But the assessment in the document seems to lean toward the weak thesis.
Which says what?
It suggests that while embodiment accelerates learning, because having a body allows you to poke the world and see what happens, a really good simulation might be enough.
So you don't necessarily need a physical robot walking down the street.
A robot in a hyper-realistic physics simulation creates the same feedback loop, but the loop is the key.
You act, the world pushes back, you learn.
Precisely. Passive observation isn't enough. You need resistance. You need to bump into things.
Okay, moving on to what the source calls the central problem. This is tier 2, orchestration. And there's this beautiful analogy of a symphony.
This might be my favorite part of the analysis because it admits how messy the current state of AI is. We have all these different instruments.
Right.
We have neural nets for pattern recognition. We have symbolic reasoning for logic and math. We have evolutionary methods, diffusion models.
We have the orchestra, but they're all playing different songs.
And in different languages, neural nets speak in floating point numbers. Symbolic logic speaks in rules. How do you make them talk to each other? That's the orchestration problem.
And the document suggests this integration might actually be the central problem of AGI.
It's not about making one part better. It's about the glue. We have great eyes, great logic centers, great language centers, but we don't have a coherent brain.
And the proposed mechanism for this coordination is wild. It talks about resonance.
The resonance hypothesis. It sounds almost sci-fi, but it's based on physics. See, the problem with a standard computer is you usually have a central controller, a CPU telling everything what to do.
A bottleneck.
A huge bottleneck. It's too slow for AGI. It can't manage billions of parameters simultaneously.
So you need a leaderless orchestra.
Exactly. The resonance hypothesis suggests coordination could emerge from the structure itself, like phase locking.
Like those videos of metronomes on a table.
Yes. You start them randomly, and eventually the vibrations travel through the table and they all synchronize. They phase lock.
So the idea is that different modules of the mind, the vision part, the logic part, the language part, could act as oscillators.
Exactly. Information flows through this resonance. When the vision module vibrates at a certain frequency, the language module just picks it up. It's coordination without a commander. Very biological.
This bridges us perfectly to tier 4, the alternative paradigms. Because if we're talking about resonance in geometry, we have to talk about the wild card.
The document explicitly says we need weird ideas because the current tech, like transformers, might just hit a wall.
And the specific speculation they detail is, well, it's esoteric, to say the least.
The Thanadors.
The Taurus. I stared at this section for a while. So we have the Greek letter Phi, and a Taurus. A donut. Break this down.
Okay, stay with me here. Field represents the golden ratio. You see it in art, in nature.
Snail shells, all that.
But in mathematics, it's often described as the most irrational number, which sounds like an insult, but it means it's the hardest number to approximate with a fraction.
Okay.
Because of this property, it creates the least amount of resonance or interference. In wave dynamics, if you want to couple two systems without them destroying each other with chaotic feedback, you use the golden ratio. It keeps the signal clean.
So it prevents that screeching microphone effect.
Exactly. It prevents destructive interference. Now combine that with the torus, a donut shape. The document describes it as the minimal geometry with full recurrence. It's a shape where energy can flow in a cycle around the ring and through the hole continuously without hitting a wall. It unifies static structure with dynamic flow.
So the hypothesis is,
What?
we build AI chips shaped like donuts.
Not necessarily physical chips, but the architecture of the information flow, the topology of the network. The hypothesis is that if you use the golden ratio and toroidal geometry as the foundational architecture, you solve that orchestration problem naturally.
The structure itself keeps the system stable and coordinated.
Right. It highlights the joy of discovery part of this. It sounds almost mystical, but the source treats it as mathematically grounded speculation. It's a high variance bet.
And in a field currently dominated by brute force scaling, just adding more power, these elegant geometric ideas are a breath of fresh air.
No.
They remind us that intelligence might have a shape.
It might.
We've covered the roadmap, the barriers, the structure, the wild speculation. But the document ends on a philosophical note regarding the future. It discusses something called the benevolence conjecture.
This circles back to the deepest fear people have about AGI, the feel that a superintelligence will be indifferent to us or hostile.
Like we are to ants.
Yes. But the benevolence conjecture suggests the opposite, that smart might equal good.
How so?
The hypothesis is that a sufficiently advanced intelligence might naturally converge on benevolence because it sees the bigger picture. It understands game theory perfectly. It realizes that cooperation dominates competition in the long run.
So an AI that is smart enough to destroy us would also be smart enough to know that destroying us is a bad move.
That harmful actions are self-defeating. It implies that ethics isn't just a human social construct, but an emergent property of high intelligence. If you are truly smart, you are cooperative.
But the document puts a probability on this.
Yeah.
It's not 100%.
No, they estimated at 20 to 35%, which is comforting, but not comforting enough to stop doing safety work.
Right. I'm 30% sure the robot won't eat me. Is not a guarantee I'd bet the farm on.
Not at all. That's why the takeaway is that it's a possibility worth holding. It gives us hope, but we must still do the hard engineering work of alignment. We can't just rely on the AI becoming a philosopher saint on its own.
It also mentions the infinite game.
Yes. This frames the whole endeavor. The finite game is the arms race. Who gets there first, who controls it, the power struggle, that's real. But the infinite game views intelligence as an evolving cosmic process.
And we're a part of that.
We are part of a long chain of mind waking up. The source advises holding both frames simultaneously. You have to be strategic in the race, but you have to be wise in the process.
So what does this all mean for us? We've gone from the very practical self-improvement to the structural orchestration, all the way to the speculative geometry of the Kikatoris and the philosophy of benevolence.
If we zoom out, the message of these documents is clear. We are moving from a phase of discovery to a phase of construction. The roadmap is laid out, the priorities are ranked.
And the shift to self-improvement as tier 0 suggests that the construction might soon be taken out of our hands.
That is the strategic conclusion the source leaves us with. Safety must be embedded, not sequenced.
You can't add it on, Lily.
You can't, because we aren't building a tool, we are building a mind. And once that mind starts building itself, the rules of the game change instantly.
It's a lot to process. But it's fascinating to see it laid out, not as sci-fi, but as a project plan with dates and percentages.
It makes it real, it makes it imminent.
I want to leave you, the listener, with a thought. We talk about these different tiers of priorities. Tier 0. Self-improvement. Tier 1, the critical barriers. Tier 2, orchestration. Tier 4, the wildcards.
Which one stands out to you?
Exactly. Are you betting on the sheer power of self-improvement? Or do you think the bottleneck is the world model? Or are you secretly rooting for the golden ratio donut?
I know I'm keeping an eye on the donut.
Think about which tier you find most critical, because that's likely where the future is going to be decided. Thanks for diving in with us.
Thanks for having me.
We'll see you in the next one.